Good day everybody. We are expected to integrate this question, integral square root of cos 2 theta over sin theta times d theta. Now I will utilize this following formula. We know that cos squared theta negative sin squared theta is cos 2 theta. So this can be rewritten as root of cos squared theta negative sin square theta times d theta. I am going to rewrite this sin theta as root of sin square theta. So this could be rewritten as square root of cos square theta negative sin square theta divided by sin square theta times d theta. Fair enough. Now I will divide by sin square theta. So this is going to give me root of cos square theta over sin square theta negative sin square theta over sin square theta times d theta. Now we know that cos theta over sin theta is cot theta. So this is equal to root of cot theta negative 1 times d theta. Now let me take this cot theta to be equal to some secant u, and I differentiate cot. Differentiation of cot will give me negative cosecant squared theta times d theta. Differentiation of secant would give me secant u tan u times du. Fair enough. Now I will keep d theta here and I will push cosecant squared theta below. So this is secant u tan u times du divided by cosecant squared theta with a negative sign. Now there is a formula. What is the formula? Let me write it like this. Cosecant squared theta negative cot squared theta is equal to 1. From here we can rewrite this as cosecant squared theta is equal to 1 positive cot squared theta. So this is equal to negative secant u times tan u divided by 1 positive cot squared theta times du. But my cot theta is secant u, so this is equal to negative secant u tan u divided by 1 positive secant squared u times du. Okay, I hope you're watching. So on the left hand side you have d theta. Okay, so let me write that down. D theta. Okay, let me move to the next page. So if I were to take this as sum 1, therefore 1 can be rewritten as integral. Now this is actually cot squared theta. Okay, because cos squared over sin squared. I just mentioned a cos over sin is cot, but it is also imperative to state that we are utilizing cot squared theta because cos squared over sin squared is there. So when we use cos squared over sin squared, apparently it has to be cot squared theta. Okay, so I hope you got that. So now this is equal to square root of, in place of cot I'm going to use secant. So you will have to use secant there. That is cot squared is present. So this is secant squared u negative 1. Now in place of d theta we have got this entire thing. So place that entire thing. We got a negative sign here. If you were to watch here, this is a negative sign. So negative sign will come in the front multiplied with secant u tan u divided by 1 positive secant squared u times du. Now we got to integrate this. Now what I wish to do is I will convert everything to sine and cos. Convert to sine and cos. So if I were to do that, now secant u is 1 over cos u. So this is going to be equal to negative of integral root of, this is 1 over cos squared u negative 1 multiplied with 1 over cos u times sin u over cos u divided by 1 positive 1 over cos squared u times du. So this is negative integral, you take the LCM as cos squared, so you get 1 negative cos squared u divided by cos squared u with the square root times sin u, cos squared u. There is also a cos squared u, you flip it, you get cos squared u, and you have to take the LCM, so it's going to be 1 positive cos squared u times the du. Now there is a trigonometric identity which states that 1 negative cos squared u is equal to sin squared u. So this is equal to negative integral root of sin squared u, square root of cos squared u is cos u, and you got a sin u there, and cos squared u gets cancelled, giving you 1 positive cos squared u times the du. Okay, now root of sin u is root of sin squared u is sin u, right? So sin u times sin u is sin squared u. So negative sign parenthesis, you get sin squared u divided by cos u times 1 positive cos squared u times du. Now you have to check if everything is fine. Okay, alright, so this is what we have got. Now we have to deal with the integration part. So what I wish to do is I will change sin squared u to 1 negative cos squared u. So this is going to be equal to integral 1 negative cos squared u. Now this is multiplied by du divided by cos u times 1 positive cos squared u. Okay, so let me go to the next slide. Now I want to get rid of this denominator. So what I wish to do is, so this is integral, I am going to add 1 positive cos squared u, but I need to get a negative cos squared u. So follow it up by adding negative 2 times cos squared u times du divided by cos u times 1 positive cos squared u. Okay, now you club these two together like this and then rewrite this as 1 positive cos squared u times du divided by cos u times 1 positive cos squared u negative 2 times integral cos squared u divided by cos u times 1 positive cos squared u times du. 1 positive cos squared u, 1 positive cos squared u goes off, a cos u and a cos u goes off, giving you integral du over cos u negative 2 times integral cos u over 1 positive cos squared u. I want to change cos squared u to sin squared, that is 1 negative sin squared. So 1 positive 1 negative sin squared u. This is what I am going to do. Okay, now you have two integrals. So if you were to consider integral du over cos u, what is that? Yeah, that is nothing but integral 1 over cos u is secant u du. But what is secant u? This is a standard formula. Secant u plus tan u plus c. This is a standard formula. So we can utilize this. Now you consider integral cos u over 1 added with 1 will give you 2 negative sin squared u times du. Now let me take sin u to be equal to t. This will be cos u du is equal to dt. I will get here dt divided by 2 negative t squared. This is rewritten as dt over root of 2 t square, root of 2 squared negative t squared. Now this is very similar to integral dx over a squared negative x squared, which has got a standard formula of 1 over 2a ln modulus a positive x divided by a negative x plus c. So utilizing this formula over here, you get 1 over 2 times of root of 2 times ln modulus root of 2 positive t divided by root of 2 negative t, which can be rewritten as 1 over 2 times root of 2 ln modulus root of 2. Now what is our t? Sin u. Place that. So sin u divided by root of 2 negative sin u. So these two components we have already got. So now what we have to do, we have to go and fuse them. Right. So if we were to take this as say 2, therefore 2 can be rewritten as, so in place of integral du cos u, I am going to write it as ln modulus secant u plus tan u negative 2 times. Now we have got this quantity, so I am going to place the quantity. So it's going to be 1 over 2 times root of 2 ln modulus root of 2 plus sin u divided by root of 2 negative sin u. Okay, we have got that out. So 2 and 2 can be cancelled. Okay, fair enough. Now we have to go and check the substitution. See here, cot theta is equal to secant u. So since cot theta is equal to secant u, we will have to bring everything to this cot theta. That's reverting it back. Now, as I mentioned to you, tan u has to also be reverted back, right? Now we have a formula. So tan squared u is equal to, what is that? 1 secant squared u negative 1, right? That is equal to tan squared u. So tan u is required. So tan u is equal to root of secant squared u negative 1, right? So fair enough. So we have got that. So I'm going to distribute this negative sign. So it's going to be negative ln modulus secant u is cot theta. Secant u is cot theta plus this is rewritten as root of secant u is cot theta. So this will be cot square theta negative 1. So rewrite that, root of cot square theta negative 1. So that is for the first part. Now we have to handle this part. We have to handle the sign. We have to get a substitution for sine. Okay, so how do we get that? So all we got is secant u is equal to cot theta. Now from here, cos u, 1 over cos u is equal to cot theta. So from here I can write cos u is equal to 1 over cot theta. 1 over cot theta is tan theta. So we have cos u is equal to tan theta. This means cos squared u is equal to tan squared u. This means 1 minus sine squared u is equal to tan squared theta. So from here 1 negative tan squared theta is equal to sine squared u. So from here sin u is equal to root of 1 negative tan squared theta. So in place of sin u, you have to place 1 negative tan squared theta. So go back here. So negative will become positive. So I am following it up here. Positive 1 over root of 2 ln modulus root of 2 positive root of 1 negative tan square theta divided by root of 2 negative root of 1 negative tan square theta positive arbitrary constant c. So that is the solution for this question. Please like, share and subscribe. Thank you.